Now we will learn about variables. A variable is something that can store information during the execution of a program. Variable can be declared by specifying the type and the name. So in this example, int is the type and I is the name. And you can also set values to variables, which is also called initializing the variable. So if I do I equals 5, then all of a sudden the value of I is set to 5. We can also declare and initialize variables in one step. So for example, int j equals 7 would declare a variable named j and initialize it to 7. You can also interact, like make variables interact with each other. So for example, int k equals I plus j would make k equal 12. And you can also print variables. So if we were to print I, that would be 5. And of course you can also print variables combined with strings and combined with other variables, potentially with arithmetic. So in this example, 5 ABC 19 would be printed because 7 plus 12 is 19, and then 5 plus ABC plus 19 is 5ABC 19. We will first go over 8 fundamental types of these variables called primitive data types, which int is an example of. The 8 primitive data types are int, double, boolean, char, long, short, byte, float. Where the most commonly used primitive data types are int and double, and maybe boolean. An int is a number from -2 to the 31 to 2 to the 31 minus 1, which you don't have to memorize. It's just around -2 billion to 2 billion. Double is just a decimal number with higher precision than float, which is a decimal number that takes up less memory space but has less precision. Boolean is just true or false. Char is a single character. Long is a number from -2 to the 63 to 2 to the 63 minus 1. Basically, if you run out of, if you surpass 2 billion in int, then you might want to use long. Short is a number from -32,768 to 32,767, which takes up less memory space. And a byte is a number from -128 to 127. Actually, by a number I mean an integer for these. So int, long, short, byte are integers. Double, float are real numbers. And then char is a character. Boolean is true or false. Int takes up 4 bytes. Double takes up 8 bytes. Boolean takes up 1 byte. Char takes up 1 byte. Long takes up 8 bytes. Short takes up 2 bytes. Byte takes up, just 1 byte. And float takes up 4 bytes. You don't need to memorize all of this, it's just for your information. You should know that int, long, short, and byte are integers, while double and float are decimal numbers, and boolean is true or false, and char is a character. So we can also declare variables of these types. So for example, of type double, we can just do that. Of type boolean, you can do that. Of type char, you can do that. Note that char has single quotes. You can also declare variables of type long. However, if the number is too big, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, then we'll get an error saying the integer number is too large. To fix that, we just put an L at the end to signify that it's a long, and then it works. We can also print these variables. However, so if we do d plus b plus c plus l, what would happen? Well, it would actually cause an error because boolean can't be merged with anything else. The rest of them can all be added. So if we make them string, then it would print 5.7 false, q, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, as shown below. You can also set like double variables to ints or less precise variables. So like double d2 equals I or double d3 equals 5 would work. However, int I2 equals d and int I3 equals 5.7 would actually both not work, as shown below, because double cannot be converted to int this way. The way we would do this would be to do int, like put int inside parentheses, which is called casting, before the variable or double number. And in this case, it would round closer to 0. So if we were to print I4 and I5, then we print 5 and -5. Another thing that's important to know is that you cannot have two variables of the same name declared in the same scope. Or in our purposes for now, no two variables can have the same name. So for example, if we try to declare int I equals 9, for example, that wouldn't work because I is already defined. If we just try to do double d, then that wouldn't work because d is already defined. If we try to do a equals 5, that wouldn't work because a doesn't exist currently. So you get the point. Also, another important thing you should know about variables is how to swap them. So let's say we have int x equals 5, int y equals 7, and so if we just perform x equals y and y equals x, then what will we get when we print them? Well, actually we would get 7, 7, as shown below. And the reason is because when we declared the variables and initialized them, x equals 5 and y equals 7, then when we set x to be y, x equals 7 and y equals 7, and we lost x. So now when we set y to be x, y is being set to 7, and then we get both of them are 7, which is not what we want. So we can fix this by making a third variable called a temporary variable that stores the information of one of those variables. That way, when we do x1 equals y1, in this case, information is not lost. then when we do y1 equals temp, we successfully swap the variables. So this would print 7, 5, which is what we desire. Another type of variable is the string, which string is not a primitive data type. Primitive data type can only store a value and is very limited, and string is not one of them. And actually, one way to help you distinguish between these is string is an uppercase, which generally should be true for all of those other non-primitive data types. And then primitive data types are all lowercase. So strings, we've been working with them all the time. Basically, they're just sequences of characters enclosed in quotes. We can print them, we can make them interact with each other. String So what would happen when we print u? Well, this is basically the same thing as if it were inside a print statement. Basically, 5 plus 7, the listing would be 12, then QWERTY, then A, B, C, D, E, F, then 57. And the reason of that is because 5 plus 7 is computed first, then 12 plus S is 12 QWERTY, and 12 QWERTY plus T equals 12 QWERTY A, B, C, D, E, F, then 12 QWERTY A, B, C, D, E, F plus 5 equals 12 QWERTY A, B, C, D, E, F, 5, and finally the result is 12 QWERTY A, B, C, D, E, F, 57. Currently, if we wanted to add a number to a variable, so for example, if we had a variable q set to 3, and say we wanted to add 4 to it, how would we do that? Well, we could do q equals q plus 4. That would make q be 7. Another way to add 4 to it would be to use a shortcut called plus equals. Basically, q plus equals 4, now q is 11. Or q minus equals 4, now q is back to 7. Q times equals 4, now q is 28. Q slash equals 5, let's say. Now q equals 5, because remember that division is still integer division when we're working with ints right here. And if you were to want to increase q by just 1, you could just do q plus plus. So now q is 6, and q minus minus would decrease q by 1, so now q is back to 5. So if we were to print these along the way, you would see down here 7, 11, 7, 28, 5, 6, 5. You could also do plus plus q and minus minus q, which do the same thing when alone. However, they're different when put inside a statement. For example, if I were to do system.out.println plus plus q, then what would happen is q is increased by 1 first, then it is printed. So then 6 is printed, shown below. Similarly, if we were to do minus minus q, 5 is printed because the subtraction is done first. However, if we were to print q plus plus, then q is printed, then it becomes 6. So 5 is printed. And then if we were to print q minus minus, then q is printed, then it becomes 5, so then 6 is printed. Similarly, we can also do percent equals, so if we do q percent equals 3, q was 5, now it's 2. And there. I'll try this one. So z1 is 9, z2 is 3, z1 percent equals z2, z2 percent equals z1. So what would this print? Well, first z1 equals 9, z2 equals 3. Then z1 percent z2 makes z1 equals 0 and z2 equals 3. z2 percent equals z1 would make 3% 0, which is an error. So actually we wouldn't even get to that print statement. What about this one? C1 equals 5.7, C2 equals 1.9, C1 percent equals C2, C2 slash divide equals C1. So what happens here when I print them? Well, actually, what would happen here is that it would actually still have an error because it stopped on the Z1, actually stopped on the Z2 percent equals Z1. So it shows that even though this piece of code doesn't have an error, the previous piece of code has an error and should be commented out if I want following code to execute. So then, given that that previous code is commented out, what would happen is C1 becomes 5.7, C2 becomes 1.9. However, C1 percent equals C2 makes C1 equal a very small positive number due to imprecision, which would make C2 a large positive number. So then when we run this, we would get something like that, which shows how imprecision can play a role in a lot of calculations in Java.